Hi everyone. Okay, so today is the last day that we are going to talk about the discrete time Markov chain, which means from next week we are going to talk about continuous time Markov chain. Okay, so today I brought several different in-class exercise problems. So here's the first set of problem. Okay, and I got this problem from one of our reference book. Introduction to Probability Models by Dr. Ross. Okay, so in this problem set, I want you to identify the classes for each Markov chain, and then after that, you can determine whether each class, all the state within each class, transient state or recurrent state. Okay, so why don't you do that? I'm going to give you maybe a couple of minutes. So please try to figure it out. Okay, this side. That's okay. Thank you. Okay, so let's work on the first case. Okay, so so it will be very easy if you draw the transition diagram based on this one-step transition probability matrix, right? So let's say we have state zero and 1, 2, right? If you say this is 0, 1, 2, 0, 1, 2, okay? So from 0 to 1, 0 to 2, and 1 to 0, 1 to 2, and 2 to 0, and 2 to 1. It's very clear that all three states communicate each other, right? Which means all three states should be in the same class, right? So I just say all of them are recurrent state, right? 0, 1, 2. Is that correct? very easy. How about the second case then? So again, let's say we have 0, 1, 2, 3. Sorry, what did I say? Also, we have 0, 1, 2, 3. Let's move this. So this time we have 4 different states: 0, 1, 2, and 3, right? And 0 to 3 is 1. 1 to 3 is also 1. And 2 to 0 is 0.5. 2 to 1 is 0.5. And 3 to 2 is 1. Okay, how about this? Again, we know that all 4 states communicate, right? So, for example, if you leave from state number 3, then you should be able to come back, right? Whichever route you take, you can always come back, returns this out, right? So again, we have only one class. And they are recurrent, right? Very easy, right? Okay, how about the third case? So let's work on P3. So now we have 5 different states. So let's say we have 0, 1, 2, 3, and 4, like that. Okay? So we have 0 to 0 and 0 to 2, right? And 1 to 0 and 1 to 1 and then 1 to 2 and 2 to 0 and 2 to 2, right? And then looks like 3 and 4 communicate, right? Okay, so we are done. So obviously, the class 3 and 4 are recurrent state, right? Three and 4. And then, how about this? You gotta be careful here. Since state 1 is transient, right? Once it leaves, you cannot come back, right? Of course, if you take this, then you stay in the state number 1. However, in other case, there is no way to return, right? So state 1 has to be transient state. In other words, 0 and 2 are recurrent state. Okay? So we have 3 different classes in this case. Make sense? Right? Okay, now let's move on to the last case. Again, we have 5 different states. So let's go with 0, 1, 2, 3, and 4. So 0 to 0, there is a transition, 0 to 1, 1 to 0, and 1 to 1, right? And 2 to 2, and 3 to 2, right? And 3 to 3, and 4 to 1, 4 to 0, right? How about this? So which states are recurrent and which states are transient? So up here, you can see that stage 0 and 1, they are communicate, right? So here, 0 and 1 are recurrent, obvious, right? What other states are recurrent? 2, right, here? So 2 is recurrent, of course. Which means all other states, 3 and 4 are transient, right? So state 3 and 4 are transient state. Is that right? Very easy. Okay. So let's move on to the next problem. Okay. So next problem is extracted from other reference book, Winston's Operations Research book. So let me hand out this to you. Okay, so why don't you take some time to read through the problem description. And try to answer for these questions. Of course, the given Markov chain is a absorbing Markov chain, right? It consists of 2 absorbing state and 4 transient state, right? So in this case, we have to use absorption analysis, right? So please try to do this. Okay, I'm going to hand out other problem sets to you. Oh, sorry. Okay, now let's work on this. The State College Admissions Office has modeled the path of a student through State College as a Markov chain here. So each student's state is observed at the beginning of each fourth semester. For example, if your student is a junior at the beginning of the current fourth semester, there is an 80% chance that he will be a senior at the beginning of the next fourth semester. So if we go up here, if students are junior, okay, junior here, right? This 4. The next 4, he will become senior with 80% of chance, right? And also 15% of chance that he will still be a junior. And a 5% chance that he will have quit. So that's about these two numbers, right? Still junior or quit, okay, next year. And we assume that once a student quits, he never re-enrolls. So that is our assumptions for the simplicity of the problem. Okay. Okay, the questions. The first question is, if a student enters State College as a freshman, how many years can he expect to spend as a student at State College? So in order to answer for this question, we do need E matrix. Is that right? How about the next question? What is the probability that a freshman graduate? Of course, we need A matrix, right? So as a first step for the absorption analysis, we need to do the matrix partition, right? So we're going to have matrix partition like this. It's very straightforward. So we have identity matrix down here and zero matrix. And where do we have Q matrix? Upper left, right? So we have Q matrix, which means this leftover becomes R matrix, right? So first, we're going to compute E matrix. And then we should be able to get A matrix, right? So could you guys work on this and let me know the E matrix and A matrix? Of course, the Q matrix is 4 by 4 matrix, so we should use 4 by 4 identity matrix for this operation. So that's going to be .9, negative 0.8, 0, 0, right? 0.9, negative 0.85, 0, 0, 0, 0.85, negative 0.8, then 0, 0, 0, 0.9. And then you have to take inverse of this, right? So does anybody have E matrix?
It's 1.11.
1.11.
0.99.
0.99.
0.99.
0.99.
0.88.
0.88.
0.
0.
1.11.
1.11.
1.11.
Okay, 1.11.
0.99.
99. Okay.
0.
0.
1.8.
1.18.
1.18.
Oh, okay.
1.04.
04.
0.00.
0.00.
1.11.
1.11. Okay, thank you. So how do you answer for the first question? Hey, if a student enters State College as a freshman, so we need to look at the first row, right? How many years can you expect to spend as a student?
The sum.
So this is freshman, sophomore, junior, senior, which means you need to add up all these four numbers, right? And how much is that? It should be less than 4. Why is that? Because some students, some entering freshman students will quit before their senior year. Okay? So I believe it should be less than 4. I'm sorry? That's 3.97. Okay. So that's the answer for this, right? First question. Now we should be able to get matrix A, right? Which is E times R. Oh, sorry. Okay. A matrix. It should be 4×2 matrix this time. So this time, it's asking you the probability that a freshman graduates, right? So within the A matrix, the matrix A, which value we need to look at? Again, starting from freshman, right? So we need to have the top row, and then the last one, right, is the graduation, which means we need this number. Is that right? Of course, this is going to be 4 by 2 matrix. But what you need is upper right corner. Okay, this value. How'd you get this? It's going to be the first row of E matrix times this last column of R matrix, right? Should be this number. Does anybody have that value? Mm-hmm. 0.75. Okay. So there is 75%. That's going to be the answer for this. Does that make sense? Okay. Okay, now let's move on to the next question. Again, I've extracted this problem from Winston's operations research books. I made a little bit of modification. So let me give you about 3 minutes. So please read through. And then this time, try to formulate the Markov chain model. Okay? And make sure your Markov chain does include 4 absorption states. Okay, so how many different states did you define? 6? How? 4? Okay, so we have 2 different opinions. So keep in mind that because it gives you the hint, right? We are required to formulate the evolution of the status of a tree. So tree, there are two different types of trees, right? The short one and tall one, right? So we have two different states already. And then the tree can be dead, right? Or it can be sold for $20, $30, and $50. So we have total 6 different states, right? Okay, so let's do that. So using the given information, we can construct a Markov chain model. Let's say the trees are 5 feet tall and shorter, right? The first stat is, let's say, 0 to 5. And then the next one is taller than 5 feet. And then, let's say, die sold for $20, sold for $30, and then sold for $50. So we have 6 different states like this. Okay? Likewise, we're going to have 6 different states. So 6 different rows as well. Okay? 20, 30, and then lastly $50. So for $50. So we have huge matrix like this. Okay? Okay, so let's go back to the problem description. It does say each year 40% of all 0 to 5 feet tall trees die. So here we have 0.4, right? And then 10% are sold for $20 each. So we have 0.1, right? And 30% stay between 0 and 5 feet. So we have 0.3, right? And 20% grow to be more than 5 feet. So we have 0.2. All others are 0, right? Make sure summation of each row in this transition probability matrix has to be equal to 1. Okay? And then here, each year, 50% of all trees taller than 5 feet are sold for $50. So we have, or the back here, 0.5. And then 20% are sold for $30. So we have 0.2, right? And 30% remain in the forest. So it's going to be down here, 0.3, right? Which means all others has to be equal to 0. Of course, once trees die, it remains as that, right? So it becomes absorbing state. The same, once the trees are sold for $20, it remains there, right? So all other states are absorbing states. Is that right? So we have this. Obviously, this is the absorbing Markov chain. So we're going to do the matrix partition like this. Oops, not this. Over here. Okay. So we have identity matrix, 0 matrix, we have Q matrix and R matrix, like this. Okay? So we already identified Q matrix, which is 2 by 2, and R matrix, which is 2 by 4. Okay? So we already did part A and part B. Now we need to compute matrices E and A. So let me give you some time. Please do this. Okay. For this problem, I have the values for both matrix. Okay. So let me write it down here. What's wrong? So E matrix has to be 2 by 2, and I have 10 over 7, 20 over 49, 0, 10 over 7. That's my E matrix. Let me know if you have different values, okay? It should be correct, because I double checked it earlier. And A matrix is 2 by 4, right? It's 4 over 7, 1 over 7, 4 over 49, and 10 over 49. And second row is 0, 0, 2 over 7, and 5 over 7. Okay? Okay, now we should be able to answer for the last two questions, D and E, right? What is the probability that the short trees will die before being sold? So which value we need to look at? So this is die, right? And then this is $20, $34, $30, and $50. And this is the short one, right? And this is tall one. Is that right? So what is the answer? This. Is that right? So the probability should be 4 over 7. How about the second question? If a tree less than 5 feet is planted, what is the expected revenue earned from that tree? Okay. Of course, that tree planted dies. Then what is your revenue? Revenue is 0, right? So $0 if it's that, okay? And then $20 multiply what? 1 over 7 up here, right? Which means instead of die here, we're going to put 4 over 7, right? From here. So continue that. That's 4 over 49 plus $50, 10 over 49. Okay? This will give you the expected revenue.
For sure.
Okay? Any questions? Okay, now let's move on to the last problem set for today. Again, I've got this problem from Winston's operations research textbook. So we just need to do the same procedure, right? Because the given Markov chain is the absorbing Markov chain, right? That does contain one absorbing state and then 3 transient state, right? So we do the absorption analysis. As the first step, we need to do the matrix partition and compute E matrix and A matrix. Then highly likely you should be able to answer for these questions. Okay? Okay, so let me give you a couple of minutes. Why don't you do that? Of course, we have Q matrix up here and R matrix down here. Okay, so here, if you read through the problem, the question, then it's very obvious you don't even need matrix A, right? So you just need to compute E matrix in this case. So please let me know if you have E matrix. Less than 100. No, it's greater than 100, right? 51 to 100, 1 to 50. Greater than 100, 51 to 100, 1 to 50. We have 3 by 3 matrix. Do you have numbers? Yeah. Tell me. I'm sorry? 16.44? 1186? Oh, only one? Okay. 1.86? Okay. Okay. 1.02? Right? 2.03? Okay. 3.22? 0.85? 1.7? 2? 3, 4? 37? Okay. Okay. Is that correct? I'm sorry, could you speak up?
For the first one,
Uh-huh.
I think it's only 6.44.
You have 6?
6.44.
6.44?
Yeah.
So instead of 16, you have 6?
Yeah.
Okay, this one. Like that? Okay, so you can double check it. Oh, 6 is correct? Okay, thank you. Okay, so since this is correct, so use this matrix E. Let's answer for these two questions. So first question, A, suppose last week the machine produced 200 units. On average, how many weeks will elapse before the machine breaks down? Because last week there were 200 units, right? So we need to look at the first row, right? Which is greater than 100. Obviously 200 is greater than 100, so we need to look at the first row. And then we need to add up those three numbers, right? So how much is that? So it's going to be a little over 9, right? 9 point something weeks, right? Is it 9.3? Okay, thank you. So 9.32 weeks until breakdown, right? Then how do you answer for the second question? Suppose last week the machine produced 50 units. On average, how many weeks will elapse before the machine breaks down? So this time we need to look at the bottom row, right? Same way, just add up these three numbers. Then it will going to give you the answer. Is that 5.06? So about 5 weeks until breakdown. Okay. Is that very easy? Straightforward? Okay. Okay, so these are all for today. And from next time, we're going to move on to the new topic, which is continuous time Markov chain. Okay? And let me know if you have any questions. Okay? Thank you. I will see you next time. Yes.
I did some research on the found this case study as an example in one paper.
What is that for? Is that for your project?
Yeah.
Okay.
There is a few states for the financial market. Like it's generally for the financial market. He provided the data as an example.
Also, where did you get this information?
From his paper, but I did.
Oh, okay. So that is from one of the journal article?
Yeah, this is first draft, so I'm not sure
Okay.
if you want to me continue on this.
It seems it's very simple.
But yeah,
Okay.
because that I just brought it. The one I found it is about the insurance company. It's with the continual Markov chain, so we didn't study the Markov chain, so I'm not sure about it.
It's fine if you do understand what they've been talking about, then you can give us presentation. That's fine.
I can apply this model in Saudi stock market model.
Okay.
But I'm not sure, like, you know, I forget the statistic, like, way to bring the probability. Because I can do, like, by calculating the number of trades per day, and take, like, sample, like, for 3 months, for example.
Okay.
But I'm not sure, like, if they are independently, the events, they are independently in each other. It's going to open, like, another door, you know what I mean?
Right, right.
So if
okay.
you want me to keep it simple, just bring the probability or just...
Right. But seems this is way too simple.
Yeah.
Is that based on journal article or some technical report or conference paper? I want you to stick to the journal article.
Yeah. Yeah, there is just one. We found like just one, an insurance company.
Okay.
I'm going to see.
Yeah, could you add up a little bit more?
Plan B.
Yeah, because this is way too easy.
Yeah.
Although this is a good example of the how Markov chain can be implemented to real world, but this is way too easy. So could you add something?
Sure.
Okay.
Like what? Like thinking maybe 3 more or 4 more?
You might want to consider maybe different scenario.
I understand.
Or
the journal is very limited.
Okay.
I don't know. Based on my research, it's like just I found one, and it's about an insurance, and it's continual Markov chain.
Okay.
Yeah, and
continuous.
Continuous, and they calculate the risk and.
It's fine because we're going to talk about the continuous time Markov chain. So
take time
it's good if you do read that article and understand, then it's still durable. You can work on that.
Sure. No problem. Sure.
Yeah.
Okay. There is a benefit of time, but I'm just.
Yeah. Okay. Thank you. Hey, India. Yes.
So I had an idea for my project.
Okay.
I don't know if you would have any time next week
Yeah.
to discuss it.
Yeah, please come over.
Okay.
So what day would be good?
Yeah, I was thinking, I was
Probably,
interested. Day, let's see, do you have office hours?
Tuesday, Thursday morning, but